Until about half a century ago, the existence of planets outside our solar system was unknown. Even experts believed that our solar system was unique and that there weren't even similar stars in the galaxy. And even if they did exist, finding them would be nearly impossible. But today, we know that this is not true. A vast variety of interesting planets and satellites have already been discovered. Hello everyone, welcome to our channel. From now on, I'm going to introduce you to the largest planet of all. To make the ranking more interesting, we'll divide them into categories, so we're not only highlighting gas giants. Jupiter, the largest planet in the solar system. Jupiter has long ceased to be considered the largest planet known to humanity. However, within our solar system, it remains unmatched. Unless the hypothesis that a brown dwarf exists alongside the Sun is confirmed, it's unlikely that any planet in the solar system is larger than Jupiter. Brown dwarfs are celestial bodies too massive to be classified as planets, but not massive enough to be stars. Still, the probability of a brown dwarf orbiting the Sun is low. Jupiter's mass is 317.8 times that of Earth, and its equatorial radius is 71,492 kilometers, which is 11.2 times larger than Earth's. Now, we'll talk about a huge exoplanet and compare it to Jupiter rather than Earth to make the numerical comparison easier to understand and avoid excessive digits. Some specialists once believed Jupiter might become a brown dwarf and serve as a companion star to the Sun. From Earth, it would probably appear as just a small, dull star floating in the sky. However, current research data shows that even though Jupiter is quite massive, it doesn't and never will have enough mass to become a brown dwarf. To become one, it would need 12 to 13 times more mass than it currently has. Even if all the other planets in the solar system were merged with Jupiter, the total mass still wouldn't be enough. Earth, the largest and most massive rocky planet in the solar system. When experts began discovering exoplanets, rocky planets larger than Earth but smaller than the ice giants like Uranus and Neptune, they had to create a new classification for them. Hence, the term super-Earth was born. Super-Earths are quite common in the universe, but for some unknown reason, none exist in our solar system. That's why Earth is considered the largest rocky planet in our solar system. Among the 4 terrestrial planets, Earth is the largest and most massive. Venus is the closest planet to Earth, with a mass 0.815 times that of Earth and a radius 0.95 times smaller. Mars and Mercury, on the other hand, are much smaller. Dwarf planets like Pluto and Ceres don't even come close. Neither do moons, asteroids, or comets. Ganymede, the largest and most massive moon in the solar system. It's a common misconception found in some online articles and old books that Earth's moon is the largest and most massive satellite. In reality, Ganymede, a moon of Jupiter, holds that title. Ganymede's radius is approximately 2,631 kilometers, which is even larger than Mercury's radius of 2,439 kilometers, the smallest planet in the solar system. However, in terms of mass, Mercury still surpasses Ganymede. Ganymede's mass is 0.025 Earth masses, whereas Mercury's is 0.055. Ganymede has a thin atmosphere composed mainly of oxygen and atomic hydrogen. However, it's so tenuous that humans wouldn't be able to breathe or walk on its surface without a special suit. There are no known life forms or liquid water on Ganymede. HD 100546b, the likely largest planet known to humanity. HD 100546 is a young, faint star surrounded by a protoplanetary disk, meaning it's in the process of forming a planetary system. This is one reason scientists are so interested in it. The star has a planet called HD 100546b, discovered in 2013. Together with its surrounding disks, this planet has a radius nearly 7 times that of Jupiter. Estimating its mass is difficult, but it's believed to be around 20 times Jupiter's mass. So it seems like this giant planet deserves the title of the largest known planet. However, we can't confirm that yet. First, it may not even be considered a planet. It could be a brown dwarf. Second, Some researchers believe the discovery itself may have been flawed. The debate is ongoing. Beta Pictoris b, the most massive confirmed planet that's not a brown dwarf. As you may have noticed, one of the challenges with massive exoplanets is distinguishing them from brown dwarfs. The difference lies in thermonuclear reactions. Brown dwarfs have already undergone them. In other words, if fusion has occurred, the object can no longer be classified as a planet. But how can we confirm whether nuclear fusion is happening from such a great distance? As mentioned earlier, a celestial body needs at least 13 Jupiter masses to become a star. Beta Pictoris b has a mass of 12.9 Jupiter masses, right at the threshold. Other objects with up to 30 Jupiter masses have been found without fusion occurring. But if the current calculations are correct, Beta Pictoris b is considered the largest planet among those that have never undergone any nuclear reactions. It's also the only planet known in its star system. Its atmospheric temperature is high, reaching around 1,724 K. Additionally, the star it orbits is very dusty, which may cause a greenhouse effect on the planet. Though it has considerable mass, Beta Pictoris b's size is not much larger. Its radius is only 46% bigger than Jupiter's. TOI 849b, possibly the largest rocky planet. It's not well defined what the minimum mass is for a planet to be classified as a terrestrial planet, rather than an ice giant like Neptune or Uranus. Traditionally, anything with less than 17 Earth masses, Neptune's mass, is considered terrestrial. But recent discoveries have challenged this notion. In July 2020, scientists discovered TOI 849b, with a radius about 3 times that of Earth. For comparison, Neptune's equatorial radius is 24,764 kilometers, nearly 4 times Earth's. Even more striking is TOI 849b's mass, over 40 times Earth's. This would normally classify it as an ice or gas giant. However, TOI 849b has a rocky surface and almost no atmosphere. Life is likely impossible there. The surface gravity is extremely high, and because it orbits so close to its star, temperatures reach 1,500 degrees Celsius, making it far from habitable. Why isn't it classified as a gas giant, then? The most convincing interpretation is that we are seeing the exposed rocky core of a gas giant. In the early stages of its formation, the star's solar wind may have stripped away the planet's entire atmosphere. In any case, TOI 849b has been immediately recognized as the largest rocky planet ever discovered. Well, until researchers find a more interesting star, this one keeps the title. If you take your eyes off your smartphone for just a moment and look up at the clear night sky, you'll see billions of stars scattered across it. Among them, there's one that shines brighter than the others around it. However, deep within the vast universe, we can't truly know what kind of battle is being waged for the title of the biggest and brightest star. Stars, much like temperamental divas, are always lurking in the cosmic shadows, ready to dethrone their rivals. In this video, we'll introduce the star that currently holds the top title among all known stars. We'll also explore why this ranking is constantly changing and why it's so difficult to determine a star's true size. The most well-known star. Since ancient times, people have looked up at the universe, trying to understand how it works. When astronomers study celestial objects, they often compare them, because comparison can reveal truths. There's one star we know much more about than any other, our own star, the Sun. It provides us with energy in the form of light and heat. Without it, life would not be possible. Sure, solar storms aren't exactly pleasant. But hey, nothing's perfect. The Sun has existed for about 4.5 billion years, and it's expected to keep shining for another 5 billion years. Its diameter is roughly 1.4 million kilometers, which is about 109 times that of Earth. Its mass is enormous, around 1.989 times 10 superscript 3 kilograms. To put that into perspective, the Sun makes up about 99.88% of the total mass of the solar system. Compared to the Sun, Earth seems fragile and insignificant. Is the Sun big or small? While it appears large to us, The Sun is actually considered an average-sized star by universal standards. In the vast depths of space, there are stars so gigantic that the Sun would look like a mere ping-pong ball next to them. So what kind of stars are these? Let's take a look at some of the largest stars ever discovered. The ranking of giant stars. While people on Earth compete to get thinner, the cosmic beauties follow a different rule. The bigger, the better. Leading this ranking is one of the most massive stars ever discovered, our 136A1, located in the Large Magellanic Cloud. This star often appears on lists of the largest stars due to its extraordinary properties. Our 136A1 has a radius 36 times that of the Sun. Not record-breaking in size, but its mass is 315 times, and its brightness is a stunning 8.7 million times greater than the Sun's. The Large Magellanic Cloud is home to many giant stars, but what astonished scientists was our 136A1 shear scale. Astronomers at the Heidelberg Institute for Astronomy in Germany developed a model for the formation of such colossal stars. According to their findings, our 136A1 became so massive by absorbing smaller stars. As a result of the stellar cannibalism, our 136A1 is doomed to die in a catastrophic supernova explosion, eventually becoming either a neutron star or a black hole. Scuti, once considered the largest. Though our 136A1 is impressive, it's not the only star that has astonished scientists. For years, when you typed, "What is the largest star in the universe?" into a search engine, the answer would often be Scuti, a red supergiant. It was once considered the largest known star. Even though it no longer holds that title, let's talk about it in chronological order. Scuti is truly colossal. Compared to it, the Sun is barely a dot. In terms of visible light, Scuti is 120,000 times more luminous than the Sun. Its volume is around 5 billion times greater. For years, its radius was estimated to be between 1,700 and 1,900 times the Sun's radius. However, that changed in 2018. It turned out there had been an error in estimating the distance between Earth and Scuti. Initially, it was thought to be 9,500 light-years away, but using data from the Gaia Space Telescope, astronomers recalculated the parallax and corrected the star's distance to about 5,100 light-years. Based on this new data, Scuti's radius was revised to approximately 775 times the Sun's radius. Still, even with the updated numbers, Scuti remains mind-blowingly massive. If it replaced the Sun in our solar system, its glowing sphere would likely reach the orbit of Mars. Since Scuti no longer holds the crown, another star now claims the title. Stephenson 2-18, an extreme hypergiant with luminosity about 437,000 times greater than the Sun's. If placed at the center of the solar system, Stephenson 2-18 would likely engulf the orbit of Saturn. Its radius is estimated to be about 2,150 times that of the Sun. However, just like Scuti, this star's exact distance may still be imprecise, leading to possible overestimations. So, are we facing another calculation error? Why can't scientists measure star sizes accurately? It's easy to criticize scientists for changing the numbers, but we must consider the immense challenges they face. Whenever we talk about massive stars, we often say things like estimated, theoretically, or approximately, because it's impossible to determine a star's exact size, mass, or diameter with 100% precision. After all, astronomers aren't placing stars on scales or measuring them with tape. A star's size depends not only on its mass, but also on its composition, evolutionary history, age, stellar winds, and other factors. For example, giant stars can have extended outer atmospheres, photospheres, that stretch across vast distances and constantly fluctuate. These stars are often enshrouded by dense clouds of dust, making it hard to measure what lies beneath. And don't forget, these stars are located extremely far away. Even though computers can simulate distant worlds in an instant, in real life, light takes tens of thousands of years to reach us from many of these stars. Despite the difficulties, technology continues to advance. Today's astrophysicists can study stars more closely using some of the most powerful telescopes ever built. both on Earth and in space. One example is the Very Large Telescope VLT, also known as the Miracle technology, located at the Paranal Observatory in Chile. Observations of the star WOHG 64 were made using this instrument. WOHG 64, the current largest known star. WOHG 64 is a red supergiant located in the Large Magellanic Cloud, about 160,000 light-years from Earth. Based on current estimates, it's considered the largest known star. Astrophysicists estimate its radius to be between 1,540 and 2,575 times the Sun's radius, and its luminosity to be between 300,000 and 400,000 times the Sun's. More recent studies suggest its radius might be around 1,800 times that of the Sun, still incredibly massive. Determining the exact size of WOHG 64 is difficult because the star is wrapped in thick clouds of dust. It's believed that these clouds have a diameter of about 1 light-year, caused by stellar winds blowing off nearly one-third of the star's mass. WOHG 64 is full of mysteries and has intrigued scientists since its discovery in 1970. It's thought to have a white dwarf companion, and its 800-day brightness variation cycle continues to puzzle astrophysicists. Despite decades of study, WOHG 64 remains an enigmatic star, with ongoing debates over its radius, luminosity, and other characteristics, highlighting the enormous challenges in understanding distant and complex celestial bodies. Our universe is filled with a vast variety of celestial bodies. Among them, there are those that cleverly hide from human observation, like asteroids and rogue planets. On the other hand, some celestial bodies boldly display their impressive magnitude. If you're fascinated by enormous things, please keep watching this video. What is a galaxy? We can't simply call a group of stars gathered for a cosmic party a galaxy. A galaxy refers to an entire system composed of stars, star clusters, black holes, planets, gas, dust, asteroids, and dark matter. All the celestial bodies within a galaxy are interconnected by gravity. Within this single space house, billions to trillions of stars and planets can coexist. Whether ancient or young, galaxies are never monotonous. A wide range of dynamic events is constantly taking place. Stars are born and die every day. Asteroids collide with planets, and black holes devour vast amounts of gas and dust. Everything is in constant motion. When we observe these dynamic processes, galaxies appear to be living creatures that feed, grow, and evolve. The true wonder of the universe lies in the diversity of existing galaxies. It's as if each galaxy wants to stand out from its cosmic peers. Among giant galaxies, the most common types include spiral, elliptical, and irregular galaxies. We live in one of the spiral arms of the Milky Way, a spiral galaxy. The appearance of spiral galaxy is quite enchanting, resembling a glowing snail shell in the dark sky of space. In terms of beauty, elliptical galaxies may be less striking than spirals. These bright pancakes can be nearly circular or highly elongated. American astronomer Edwin Hubble classified elliptical galaxies as early-type galaxies. He speculated that elliptical galaxies evolved into spiral galaxies over time. However, modern astrophysicists disagree with this view, suggesting instead that spiral galaxies eventually transform into elliptical galaxies as they evolve. We can verify this ourselves. Just live a few dozen billion more years and see what shape the Milky Way will take. On the other hand, irregular galaxies are whimsical wild cards. These galaxies can change shape due to gravitational interactions. It's precisely because each galaxy is a unique entity that makes everything so fascinating. The size of galaxies. Understanding their size becomes evident through comparison. When it comes to galaxies, we immediately associate them with dazzling light and immense scale, and that's absolutely true. Galaxies are incredibly large, often beyond human imagination. But when we compare them to one another, we find that the universe hosts everything from adorable tiny galaxies to monstrous giants. Our home is the Milky Way. For a long time, it was believed to be the largest galaxy in the universe. And no wonder, its diameter exceeds 100,000 light-years. In other words, it would take light 100,000 years to travel from one end to the other. Even the fastest spacecraft would take practically an eternity to cross that distance. According to conservative estimates, the Milky Way may contain between 100 billion and 400 billion stars. Is that a lot? Actually, that's a pretty respectable size for a galaxy, especially when compared to galaxies like Segway 2. This tiny galaxy was discovered in 2007. It's a spheroidal galaxy located in the constellation Aries and is considered the smallest known galaxy. Calculations indicate that Segway 2 contains only a few thousand ancient metal-poor stars, supporting the idea that it is very old. Its luminosity is about 1/20 billionth that of the Milky Way, and its diameter is just over 220 light-years. In other words, if we place Segway 2 next to the Milky Way, the latter would appear absolutely gigantic. Still, in cosmic terms, our galaxy isn't particularly large. When compared to monstrous galaxies, it's more like a grain of sand. Ranking the largest galaxies. If there were a contest to determine the largest galaxy in the universe, the title holder would change constantly, thanks to technological advances and improved telescopes. Astrophysicists are always discovering new galaxies. They must have been amazed to find Galaxy 3C348, also known as the Hercules A galaxy. According to rough estimates, this galaxy is about 125,000 light-years across. However, the black hole at its center has a mass about 1,000 times greater than the one at the center of the Milky Way. This black hole consumes surrounding matter at an incredible speed, releasing powerful jets of material into space at near light speed. But even this galaxy pales in comparison to IC 1101. Hercules looks like a skinny teenager next to a bodybuilder. For a long time, IC 1101 was considered the largest galaxy in the observable universe. Located in the constellation Virgo, about 1 billion light-years from the Sun, IC 1101 reached its enormous size through cosmic cannibalism and an insatiable appetite. If you devour everything in your path, you're bound to grow huge. Let's compare IC 1101 to our beloved Milky Way. IC 1101's diameter is approximately 4 million light-years, and if we include its halo, that grows to 6 million light-years. Scientists estimate it contains around 100 trillion stars. In other words, it is 60 times larger than the Milky Way and 20 times as massive. It's a bit unsettling, isn't it? Now we can understand how tiny little Segway 2 must feel, surrounded by such giant neighbors. But even IC 1101 has to step down from the throne in favor of UGC 9555. This radio galaxy measures a staggering 8 million light-years across. Determining its total mass is a challenge, but it's likely to contain trillions of stars. UGC 9555 was discovered by an international group of astrophysicists, and research on it is still ongoing. And yet, it still doesn't surpass its closest rival, 3C326. This radio galaxy measures about 15 million light-years in length and is located in the Serpens constellation. A key feature of 3C326 is its double-lobe radio structure. It's currently being studied in detail. Who knows, we might learn something surprising about it soon. If you've never heard of Alcyonius, you might not know much about giant galaxies. This galaxy overtook 3C326 by a narrow margin to become the new champion. The discovery of Alcyonius happened in 2022 when researchers from the Leiden Observatory, led by graduate student Martijn Oyai, gathered radio observation data from a northern sky using low-frequency interferometry. What they found were radio lobes, a common feature in this type of galaxy, indicating the presence of a supermassive black hole at its center. The black hole in Alcyonius has an astonishing mass. For 100 million times the mass of the Sun, scientists were able to observe the red-tinted radio lobes thanks to a new device called LOFAR, Low Frequency Array, a network of radio telescopes located in several European countries. The galaxy turned out to be unbelievably large, unlike anything scientists had ever seen before. Its total length is more than 16 million light-years, about 160 times the size of the Milky Way. To help you visualize the scale, imagine ants and elephants side by side. The ants represent the Milky Way and the elephants Alcyonius. In fact, the diameter of Alcyone is 72,000 times that of Segway 2. Compared to it, Segway 2 might as well be a single cell, or perhaps even an atom. The universe resembles a Russian nesting doll. Every large structure contains a smaller one inside, and within that, an even smaller one. Within a vast cosmic void known as a void, massive threads of galaxies, called filaments, stretch across millions of light years. These filaments are made up of galaxy clusters, and within those clusters are countless independent star systems called galaxies. It seems galaxies, much like humans, don't enjoy solitude. In fact, nearly every galaxy belongs to some kind of cluster. Sometimes, they come together to form gigantic groups with diameters spanning millions of light years. The total mass of these clusters can exceed trillions of times the mass of our sun. Would you like to see them? Today, we'll take you on a wonderful journey through the most massive galaxy clusters in the universe. Before we begin, it's important to clarify, we'll be talking only about galaxy clusters, not superclusters. Unlike superclusters, galaxy clusters are gravitationally bound to each other. This makes them the largest systems of mutual interaction observable in the universe. Over tens of millions of years, the celestial bodies within superclusters will gradually drift apart, eventually disappearing from view, assuming there are still humans around to observe them. In a way, superclusters are like an illusion, a temporary residence. Galaxy clusters, on the other hand, are like solid homes, structures that maintain their shape over a very long time. There are two main types of galaxy clusters, regular and irregular. Regular clusters are symmetrical, often nearly spherical in shape. The closer you get to their center, the higher the density of galaxies. Most are composed of elliptical and lenticular galaxies, many of which look nothing like our Milky Way. Irregular clusters, by contrast, lack symmetry and have no defined shape. They often contain a variety of galaxy types, including spiral galaxies. Each galaxy cluster is made up of thousands of galaxies. Surprisingly, the majority of their mass isn't composed of galaxies or even the sparse gas that spreads through them, but rather of dark matter. This mysterious, invisible force is believed to be the true source of gravity, and it may account for up to 90% of a cluster's total mass. Now that we understand what galaxy clusters are, let's dive into our ranking of the most massive ones in the universe. Pandora's Cluster, Able 2744. Also known as Pandora's Cluster, Able 2744 earns its poetic nickname due to the many strange and fascinating phenomena it hides. Located in the Sculptor constellation, this cluster spans about 4 million light-years and weighs approximately 4 trillion times the mass of the Sun. When observed through telescopes, we witness a cosmic cataclysm. At least 4 smaller clusters are colliding in this region. Scientists use different wavelength bands to observe this collision, which has been unfolding for about 350 million years. Within Pandora's cluster, several electromagnetic sources were detected, believed to be the remnants of those collisions. At its center are extremely massive galaxies that function as gravitational lenses, distorting light, and allowing us to see even farther into the universe by observing smaller, more distant celestial objects behind them. Galaxy Cluster IDCS 1426. With a mind-blowing mass of 500 trillion times that of the Sun, Galaxy Cluster IDCS 1426 holds the title of the most massive cluster known from the early universe. It lies 10 billion light-years away, meaning we see it as it was when the universe was only 3.8 billion years old. At its bright central region, a strong X-ray source has been observed, evidence that it likely merged with another massive cluster about 500 million years ago. Astronomers suggest that the material in its core is violently ejected outward, like wine swirling in a glass. Other areas contain extremely hot gas. This rapid development suggests that IDCS 1426 formed unusually fast for such an early stage in the universe's history, forcing scientists to potentially revise their understanding of cosmic evolution. The Virgo Cluster. Not all massive clusters are located at the edges of the observable universe. One of them is actually relatively close to Earth, the Virgo Cluster. This is the closest large galaxy cluster to us, situated about 50 million light-years away, a short distance in cosmic terms. It's named after the Virgo constellation, which lies at its center. More than 2,000 galaxies are part of this cluster and has a total mass of 1 quadrillion solar masses. That's a 1 followed by 15 zeros. It spans roughly 14 million light-years in diameter. Most of the galaxies in the Virgo cluster are spirals, but the 4 brightest and largest are ellipticals. One of them, Messier 87, became famous when a black hole at its center was captured in the first ever black hole photograph. The Phoenix cluster. The battle for the most massive galaxy cluster is fierce, with only slight differences in mass separating contenders. Currently sitting in second place is the Phoenix cluster. It has a mass of about 2 quadrillion solar masses, 2,000 times greater than the Milky Way. In X-ray wavelengths, the Phoenix cluster is the brightest known cluster, emitting about 35% more X-rays than previously observed giants. This brightness comes from its rapid loss of heat, which triggers intense star formation in its central galaxies, up to 740 stars per year. That's hundreds of times faster than the Milky Way. This is especially impressive considering that central galaxies and clusters are usually among the oldest and often no longer produce stars. But Phoenix is different. Its secret might lie in the supermassive black hole at its center. Scientists believe this black hole is releasing energy that prevents surrounding gases from cooling, keeping the star-forming engine active. It's a mystery researchers are eager to solve. El Gordo, the Fat One. Now it's time for our champion. Nicknamed El Gordo, Spanish for the Fat One, this cluster has a perfect name. According to multiple estimates, its mass is somewhere between 2 to 3 quadrillion times the mass of the Sun. El Gordo is located 7 billion light-years from Earth and is a result of 2 independent clusters colliding at millions of kilometers per hour. This massive collision gives El Gordo a long tail in astronomical images, much like a cosmic comet. What's especially intriguing is how dark matter behaves differently from normal matter here. While the high-temperature gases that make up most visible matter slow down during the collision, dark matter does not. It keeps moving. That separation between dark and visible matter makes El Gordo a prime subject for ongoing research into the nature of dark matter itself. Standing next to these cosmic titans, don't you feel like a tiny grain of sand? Even the Milky Way seems small in comparison, but at least it's a cozy little home. And honestly, I'm already missing our solar system and this beautiful little planet we call home. Black holes, the monsters of the universe. Black holes are the most terrifying and mysterious celestial bodies in the entire universe. Their gravity is so strong that not even light can escape. The point of no return, which separates the inside from the outside of a black hole, is called the event horizon, and what lies beyond it is a complete mystery. No one knows for sure what happens in there. We can only imagine. Physicists believe that at the core of a black hole lies a gravitational singularity, a point in space-time where mass, density, and curvature become infinite. Writers of science fiction imagine something else entirely. A hidden portal inside black holes that could take us through wormholes, enabling long-distance space travel, time travel to the past and future, or even journeys to other dimensions. And Hollywood? They imagine black holes with endless floating bookshelves. Hey everyone, how's it going? The mysterious interior isn't the only spectacular thing about black holes. Their physical features are just as mind-blowing, especially their mass. In fact, did you know black holes are considered bald? That means to fully describe them, you only need to know 3 things: mass, electric charge, and spin. A black hole size is defined by its mass. For example, if you wanted to turn Earth into a black hole, you'd have to compress the entire planet into a ball just 9 millimeters wide. Wild, isn't it? Types of black holes. Smaller and lighter black holes form when massive stars collapse after burning through all their fuel. Once a star can no longer generate enough pressure to counteract gravity, it begins to collapse inward. Eventually, it implodes and becomes a black hole, usually with 5 to 10 solar masses. By the way, scientists don't use kilograms or tons to measure celestial objects. Instead, they use solar masses, which are based on the mass of our sun. But not all black holes are small. There are true giants called supermassive black holes, containing millions or even billions of solar masses. These monsters are usually found at the centers of spiral and elliptical galaxies. Scientists still don't know exactly how they form, but theories suggest they may arise from the collapse of huge regions of matter at galactic centers, or from the merger of several stellar mass black holes. Our own Milky Way has a supermassive black hole at its center, with 4 million solar masses. But compared to the ones we're about to explore, it's just a baby. M87. This image, captured in 2019, is the first real photograph of a black hole. The glowing orange ring surrounds the shadow of a black hole located in the elliptical galaxy Messier 87, M87, about 50 million light-years away from Earth. This black hole is so massive that all 8 planets of our solar system could fit inside its event horizon. Its mass? An astonishing 6.5 billion solar masses. And it's aggressive. As it devours surrounding matter, it heats it up and emits intense X-rays, while ejecting a magnificent plasma jet stretching 5,000 light-years across space. NGC 1600. Imagine walking through a neighborhood of 2-story homes, and suddenly you see a 100-story skyscraper. That's how scientists felt when they discovered the galaxy NGC 1600, located in the center of a small galaxy cluster with only 20 galaxies. To their surprise, at the heart of NGC 1600 lies a supermassive black hole with 17 billion solar masses, a true behemoth. What shocked scientists most was the ratio between the galaxy's mass and the black hole's, which is about 10 times greater than normal. It's possible this black hole formed after 2 galaxies merged, with their central black holes eventually combining into one. Phoenix Cluster. The Phoenix Cluster is a massive group of thousands of galaxies, located about 5 billion light-years from Earth. At its core is an enormous galaxy that produces new stars at an incredible rate, between 500 and 800 solar masses per year. The engine behind this extreme star formation? A supermassive black hole. Normally, black holes of this size heat up surrounding gas and prevent star formation. But in Phoenix, the opposite is happening. Cooling gas and dust flow outward from the center, forming long filaments where new stars are born, rising like a phoenix from the ashes. The central black hole here is no slouch. It has 20 billion solar masses and is still growing fast. In fact, it gains about 60 solar masses per year. At some point, it will grow so large that it will stop new stars from forming. But for now, it remains a cosmic star factory. Quasar 5S0014+81. The beacon of the universe. Quasars are some of the brightest objects in the universe, and they are powered by black holes. A quasar forms when a supermassive black hole starts consuming nearby matter, creating an accretion disk that shines with intense energy. The resulting light can outshine entire galaxies, which is why quasars are often called the lighthouses of the universe. Located in the constellation Cepheus, the Quasar 5S0014+81 glows with a luminosity 300 trillion times greater than the Sun's. Scientists estimate the mass of the black hole behind it to be around 40 billion solar masses. To give you an idea of its scale, 40 Plutos could orbit inside its event horizon. TON 618. Now it's time to meet today's winner, the largest black hole ever discovered. TON 618, located in the constellation Canes Venatici. This colossus has an estimated mass of 66 billion solar masses. Yes, 66 billion. Surrounded by a glowing accretion disk of hot gas and dust, TON 618 spins at unimaginable speeds, up to 7,000 kilometers per second. It is located about 10 billion light-years away and shines with 140 trillion times the brightness of the sun. TON 618 is so bright that it completely outshines its host galaxy, which we can't even see. Due to its immense size and unique nature, scientists propose a new classification, the ultramassive black hole. In the past, during a time when it was said that the sun shone even more intensely and the fields were lush and green, the peak of technology was represented by the typographic printing press and fuse locks. The human world was confined to the solar system. Beyond it lay the celestial sphere of fixed stars, and beyond that, only the Creator. Hundreds of years have passed since then, and we've learned many new things about this world. At the same time, we discovered that our solar system is nothing more than an insignificant grain of sand when compared to the true scale of the universe. As time goes on, more and more cosmic structures are being discovered. And today, on our channel, we're going to talk about one of the most astonishing of them all, the Hercules Corona Borealis Great Wall. How was the Great Wall discovered? Research into the large-scale structure of the universe inevitably comes with challenges and difficulties. Observing stars near Earth isn't too complicated. After all, it's something humanity has been doing since ancient times. Even though our technology has advanced for thousands of years, the basics remain the same. Just like our distant ancestors, we still gaze up at the starry sky. However, when it comes to distant galaxies, things become a lot trickier. That's because they appear very small and blurry. Thankfully, we've found ways to overcome this issue, for example, with space telescopes that orbit Earth. But when it comes to cosmic structures billions of parsecs away, the situation changes completely. Imagine this. Inside one of the rooms of your apartment, there's an ant sitting on a wall. If the ant is in the same room as you, maybe it can observe its surroundings using a tiny ant-sized telescope. But how could that ant possibly get a view of the entire apartment, or the whole building, or the street outside, or even an entire city? Even if the ant could see through the wall, it wouldn't be enough. That's why researchers are constantly developing new ways to observe distant objects and improving the techniques they already have. One of these methods involves tracking gamma-ray bursts, which occur in distant galaxies. Gamma-ray bursts are astonishing phenomena. They're extremely powerful energy emissions that can be detected across vast cosmic distances. A single burst could wipe out all forms of life across an enormous area. Fortunately, this is a rare event, occurring only once every few million years per galaxy. In 2013, researchers from the United States and Hungary analyzed data on gamma-ray bursts collected by the Swift Space Observatory. They mapped these bursts onto a celestial chart. As a result, they discovered that during the observatory's years of operation, 19 gamma-ray bursts had occurred in a particular region of the sky. Now, if something so rare is happening so often in the same location, there's only one possible explanation. There must be an immense concentration of matter in that area, something that challenges all our traditional assumptions. Another brick in the wall. As research progressed, scientists became more and more confident. What lay ahead of them was a massive cosmic wall, what would come to be known as the Hercules Corona Borealis Great Wall. When we observe the universe on the grandest scale, it starts to resemble a kind of honeycomb. Matter clusters into filaments and walls, forming the boundaries of vast cosmic voids. We're not just comparing ants on a wall to humans for no reason. The universe, in many ways, really is like a skyscraper. And that wall the researchers found? It's been named the Hercules Corona Borealis Great Wall. Similar structures have been found before, such as the Sloan Great Wall in 2003. However, what was discovered this time was significantly larger than anything scientists had ever seen. The Hercules Corona Borealis Great Wall is located 10 billion light-years from Earth. Its length alone is 10 billion light-years, and its width is around 7 billion light-years. To put that into perspective, the Milky Way is less than 200,000 light-years in diameter. The distance from us to the Andromeda Nebula is just 2.5 million light-years. Compared to the Great Wall, any galaxy is just a tiny brick. And stellar systems? They're smaller than atoms. It's likely that millions of galaxies exist within this massive structure, and undoubtedly, trillions of stellar systems. Even if it were technically possible to teleport instantly from one star system to the next, spending only 1 second in each, a human being wouldn't live long enough to visit even 1,000 of all of them. So far, the Hercules Corona Borealis Great Wall is the largest known structure in the universe. It accounts for roughly 10% of the diameter of the observable universe. It's as if humanity has reached the outer wall of the skyscraper, and we're left standing here, staring at it from a distance. It's a bit disheartening to only be able to admire the majesty of this structure from afar. Will humanity ever be able to send a probe that far before the sun expands into a red giant? Only time will tell. As we often say in our videos, the universe is a mischievous trickster. Whenever humans build a system of knowledge that seems solid and reliable, the universe throws something unexpected into the mix, knocking all down like a house of cards. The Great Wall isn't just a massive, magnificent structure. It's also a cosmic curveball thrown our way. The great British astrophysicist E. Arthur Milne introduced the idea of the cosmological principle back in 1935. This principle is based on two assumptions: homogeneity and isotropy. Homogeneity means that, on average, the universe looks the same no matter where you're observing it from. Whether you're on Earth in the Andromeda Nebula or at the most distant known galaxy, UDF 38135539. Isotropy, on the other hand, means there's no particular direction in space that leads to a higher or more complex cosmic structure. Let's break that down in plain language. If we observe the hierarchy of planets, star systems, and galaxies from Earth, we can identify a direction relative to the center of our stellar system, the Sun, and from the Sun, we can find a direction toward the center of the Milky Way. But for the universe as a whole, there is no center and no directional hierarchy beyond our galaxy. The cosmological principle is considered the foundation of all astronomy. In particular, it supports the concept of the end of greatness. This means that at about 300 million light years from Earth, the universe should look the same in every direction. What we should see is just a general cluster of galaxies and nothing bigger. But by now, you've probably figured out the problem. The Hercules, Corona Borealis Great Wall, seems to be mocking the cosmological principle, like a scientific joke at our expense. We're trying to prove the wall doesn't exist while standing right in front of it. The first doubts about the cosmological principle arose in 2003 with the discovery of the Sloan Great Wall, a colossal structure 1.5 billion light years in size. At the time, researchers called it an anomaly, something rare and exceptional. Still don't get it? Let me explain again, so said the universe. Then came another discovery, the huge LQG Large Quasar Group in the Leo U-1.27 region, which has a maximum diameter of 4 billion light years. And finally, the Hercules Corona Borealis Great Wall. As if the universe whispered, "Checkmate, cosmologists." The biggest mystery of all is how this wall formed. Even more puzzling, we are looking at it as it was 10 billion years ago, when the universe was only a quarter of its current age. Whatever force formed the Great Wall must have begun acting shortly after the universe's birth. Could it have been the gravitational influence of another universe? And with that, we've reached the end of another video here on our channel. Thank you so much for watching all the way through. We still know so little about the universe, and that's why we keep learning, even as we're constantly surprised by new discoveries. Who knows? Maybe in the near future, we'll find something even more magnificent and mysterious than the Hercules Corona Borealis Great Wall. If that happens, you can count on us to bring it to you right away. So be sure to come back, share this video with your friends, hit the like button, and subscribe to the channel so you don't miss any of our future content. It's time to say goodbye. A big hug, and see you next time. Bye-bye.